All right, today is August 3, 2018. This is the meeting of the CSI implementation group. So today, the agenda is a little bit different from usual. Instead of doing this usual status overview, we're going to discuss the kubelet device plugin registration mechanism. We have guests from the GPU team who helped design and build that feature. And they're going to discuss the roadmap and see if we can get alignment with CSI because it's a key dependency for CSI. So with that, I'll hand it to Renaud. Am I pronouncing your name right?
That's good, yeah.
Okay, cool. So take it away. I guess you can give introduction and.
Hello everyone. I'll start by sharing my screen first of all. And I've just shared a document to the chat that is a link to the current document. So I'm from NVIDIA. I've been mostly active in the device manager part of Kubernetes, and Vikas maybe is on the call. Jaying is also on the call. They've been also active on the plugin watcher side. So we've been discussing a bit on the plugin watcher beta graduation. As Saad mentioned, this is a key part of the CSI. And we're here mostly to discuss what can be pulled and what are what is the minimal set of features that would need to be implemented for the plugin watcher to graduate in beta in 1.12. So in the document, I've basically pasted the requirements for the beta for graduating a feature to beta. And I've also pasted some of the discussions that we've had on what we would like to see in the plugin watcher. There are a lot of features that you can find on the umbrella issue. I think we'll have to update that umbrella issue to match the features that we would like to discuss. So one of the discussions that we've had with that is mostly that the core feature of the plugin registration is the GRPC API. And this is basically graduating that feature to beta would mean that we would likely not break the GRPC API. The discussion that we've had is that the GRPC API is pretty stable. What we are not sure about is the interactions between kubelets and the plugins themselves using that API. So I've basically listed 5 different features that I think are really important. Having the plugin watcher be used by multiple plugin systems. Thanks to Vikas's PR, this is currently the case right now. It is used by CSI and the device manager. Finalize the GRPC API. So this is mostly about changing v1 alpha to v1 beta for the API. Finalize the lifecycle interaction API behavior. I think this is the one that needs the most discussion. And then implement E2E tests and make sure the documentation is up to date.
Yeah, that looks solid to me.
Okay. A small note for E2E test. The device manager has been updated to test. The device manager E2E test has been updated to test the plugin watcher.
Sorry, it's E2E node test, not E2E test. I think we actually also want the E2E test, the cluster level E2E test. That'd be more ideal.
Yep. Actually, that's something that's a really good point. What I really think was important on this part was about mostly making sure that this E2E test is focused on testing the lifecycle of the plugin watcher. I'll go back to the E2E test. I think this is really the most important part is the lifecycle, is about discussing how exactly we expect these to interact. Are there any questions about mostly the agenda for that? Or can I continue on the life cycle?
I have a question. So you mentioned the ideal date for J is a Q file. I want to understand where this like a timeline is from. Is it because something depends on this, or is this because we feel this is the ideal target date?
Are you asking about the CSI timeline or the?
No, so the J by Q4 is CSI timeline, not the
Yes.
timeline. Oh, okay.
Right.
Sure.
So that's kind of what's driving this. I think Renaud had his own timeline, which was maybe a little bit slower. And when we discussed, I think I'm the one who's kind of putting the pressure on this because we want CSI to GA by Q4.
Oh, so that makes sense. But I think for CSI GA, this feature only need to be beta, right? I mean, the plugin module doesn't have to be GA at that time.
I'm not sure. Ideally, I want it to be GA. That way, you know, we don't have any breaking changes moving forward. But I think with beta, breaking changes from between beta and GA, breaking changes could happen theoretically. And so for a GA feature to depend on a beta feature, I'm not sure if that's okay or not. I think it's not. So
you're saying the plugin is beta, and so the statement OpenShift's putting forward is that the CSI interface will be GA. The plugins themselves will be beta, right? And we plan to add beta features to the interface moving forward that we will eventually GA. But
yeah.
The core of the
and as far as I'm concerned, this plugin management protocol is part of the CSI interface.
Okay.
Just because it's not part of the CSI, you know, spec doesn't mean it's not part of the interface.
Right, like the rest of our 4 or 5 bridge components.
Yeah.
So quick note. The way that we understood beta and the device manager is that we can make breaking changes. What that, however, means is that we need to support both versions in beta if we're making a breaking change.
Yeah. So
I think that's correct. Yeah.
And if that's the case, then ideally we want the GRPC component of this to go GA at the same time as CSI.
Quick note, however, the point of this meeting is to plan to have those breaking changes be in alpha rather than in beta.
Yep, that makes sense.
So in the umbrella issue, I've basically tried to list all the features that would basically allow the plugin manager to graduate to GA. As I was mentioning, we'll change the timeline, but if this is a comprehensive list, basically the impact that I see for all these features are mostly around the life cycle around registration and re-registration, deregistration, and the plugin registration notification. I've made a small, basically a very simple slide that details what exactly is the current lifecycle. So the first, the current lifecycle is a device plugin place its socket in the agreed path, in the kubelet path. Kubelet will call the GRPC get info. We'll call the get info GRPC call on the plugin. It will then validate that plugin inside kubelet. We'll call the notify registration if everything went correctly, and then hand over that part to the device manager or the CSI manager. And this is done sequentially. Actually, the remove socket part is something that we are planned, but this is basically the current lifecycle. What we're discussing right now is multiple things. The first one is the simplest one. We are discussing about making sure that we all agree on this part, that is, if a plugin removes its sockets, it means that a plugin is now deregistering. The second part is about registration and re-registration. So what happens when a plugin, say, nvidia.com/GPU registers, and then nvidia.com/GPU-1.9 registers after that with the same resource name. This is important mostly in the case of zero downtime upgrades, because we want to be able to have plugins at least upgrades, and we want to be able to switch between versions as a plugin. What we call re-registers, and that has impacts on placing the sockets and the notify registration part.
Renaud, quick question. You mentioned that it re-registers with the same name, but in fact you provided a different name, because NVIDIA IO/GPU, it's one name, and NVIDIA GPU-1.9 is a different name.
That is because the file system socket name does not have to match exactly the resource name the plugin advertises.
Also, they will use the same socket name.
They would not use the same socket name, but they would use the same resource name. The resource name is the name advertised at the kubelet level. So if we go over maybe
sorry, Renaud. So
yes.
for your plugin, are you talking about the case that plugin is managed by daemon site, or you are thinking like the plugin can be some software running on the machine? I think for zero downtime upgrade, currently daemon side works. The way daemon side works is it always turns down the old version of pod and then start new version of pod. Yeah, just want to understand whether the requirement is because you want to run device plugin as a environment.
Maybe I can detail that a bit more. First of all, I want to go over the question that was just asked before, is that so when a plugin places its sockets at the agreed path, the socket name does not have to match the name advertised in the plugin info. And on the device manager side, that string name is advertised in the node resources. So for example, nvidia.com/GPU. And we do not, at least in the device plugin part, we do not have a hard requirement that the socket name or socket path matches that that string name. And what the use case that I was mentioning is that you can imagine for example, a device plugin that runs inside a daemon set that is, for example, 1.9.5. And that device plugin 1.9.5 places its socket, for example, in nvidia.com/GPU 1.9.5 and advertises nvidia.com/GPU on the node. Later in the cluster's lifecycle, maybe a month from there after that, the cluster admin decides to deploy a second daemon set that has the device plugin for 1.9.9. And that device plugin is deployed at the same time as the 1.9.5 device plugin. And so both pods are coexisting on the same node. What the device plugin on 1.9.9 would do is that it places its sockets at nvidia.com/GPU-1.9.9. And what ideally would happen is that the kubelet sees that new socket, goes through the registration process, sees that the device plugin advertises nvidia.com/GPU, and once it has registered the device plugin, makes the switch over to that new plugin. And the cluster admin can then remove the old device plugin.
Yeah, that seems reasonable to me. I don't have any concerns with it. I don't think that it's a huge use case for CSI because we can tolerate a little bit of downtime. when we're doing upgrades because it's not part of the critical serving path. It's only responsible for basically getting pods ready. Once the pod is started, it gets out of the data path. It's not part of the data path. So, but it would be nice to have.
Yes, it's actually interesting to know, like on CSI side, this is not a typical pattern like you may expect people to use, because I think even on device plugin side, typically we expect the way to handle device plugin upgrade is like the new version of the device plugin can like support both versions if the purpose is to deal with the old version of Kubernetes or the old version of device plugin API from Kubernetes side. So I think the typical pattern we want to see from upgrade is the people will roll out a new version of daemon side, and they can set the tolerance, those requirements in the daemon side spec, and do the rollout gradually instead of deploying two daemon sites. And so I'm actually not sure the priority of supporting this pattern. And be interesting to learn from CSI side whether this is a typical pattern you consider it's important.
Maybe I can chime in here and mention that in terms of work necessary, sorry, I'll close down my Slack. In terms of work necessary, I believe that on the lifecycle part, it is not a huge task. And so if that is not something that is a priority important, I completely agree that we might want to remove that from the beta timeline. However, I don't believe that there are a lot of basically tasks that are needed to that what I'm basically trying to say is that there are 4 different tasks that would basically needed, I consider important for the beta graduation. And I don't think the work needed is that we're trying to remove features from that because in terms of work needed, we're talking about maybe 1 day or 2 days of work, and then probably a week or 2 of approval.
Yeah, that sounds good. I think we may just mark this 0 downtime as optional, and then we will evaluate after we see the changes required.
Yeah, I mean, in terms of how we do planning, we can just put priorities on these different features. So for example, registration, deregistration, clearly P0s. Re-registration, we can mark that as like a P2. And plugin registration notification is important as well. So that seems like a P0. And then in terms of PRs, it's up to you. I see Renaud, you as like the tech lead of this feature. If you think you have the capacity within your team for all 4 of the features, that's awesome. We get more functionality. If we need to, make a call, that means that re-registration can get deprioritized for these other features.
Yep. I'm good with that. I was actually, as I was mentioning, I didn't mention that, but I'm happy to take ownership on this life cycle part. I'm mostly my question was really more about or in terms of what I wanted to figure out in this meeting is who are the approvers that are needed, and who's willing to basically be a reviewer on these parts. Because I think this is because the bottleneck really here is about the reviewing process, and I want that I would like to have basically these people figured out.
Got it. So from the CSI side of things, I think Vlad and Sergey are going to be the main reviewers. Vlad and Sergey, are you okay with that?
That's fine.
Yep.
Cool. And then on the GPU side, I think it's up to Jiaying.
Yep.
I will think with Vikas to say whether he has cycle or like I think I may share that with Vikas.
On the end-to-end test part, Jane, you mentioned that you wanted a not an end-to-end node test, but an end-to-end test. What did you have?
I want both. We already have between node part, and in addition to that, I also hope we can have an E2E test.
Do you want to take ownership on that, or?
So actually, I feel this part is related to some of the device plugin work we have been hoping to make progress. So we have been mentioning in the device plugin discussion, like we want to have a stub device plugin based E2E test for quite a while. And I really hope we can make some progress in 1.12 cycle. So once we have that, then we should be able to exercise this plugin voucher registration and deregistration part. And also once we have that, we can add that to the cluster upgrade and downgrade test. And that will also exercise the life cycle part. But I also
can I mark you as an owner for this then?
Sorry?
Can I mark you as an owner for this then?
Okay, you can mark me as owner, and I will find the owner from device plugin part, and then I may modify this part. But I also hope, like from CSI part, I guess you also have planned to have some integration tests.
Yes, so we do plan to have end-to-end tests for CSI that will exercise this code path essentially, but it'll be end-to-end for CSI and volumes.
I think as long as it exercises this part, and I guess you will also add that test to the cluster upgrade and downgrade tests eventually. I think that will exercise the plugin voucher lifecycle from CSI part, and perhaps they will serve most the purpose to verify the lifecycle.
Yeah, maybe we can break this item down into multiple items with multiple owners. So CSI end-to-end tests, I think Vlad and Sergey can take ownership of that. And then I think you mentioned a end-to-end lifecycle test, and you mentioned a node end-to-end test, and I'm not sure what else there was.
The node end-to-end test is already implemented.
Okay.
So that answer. Yeah. I hope I'm not destroying anyone's name.
It's SERGUEI.
Okay, thanks. That's the owners. I guess this is the part where I think because E2E tests are in the general namespace, I believe, do we have someone that has approval privileges for that?
I do.
Okay, cool. And cluster, so we also mentioned lifecycle E2E tests. And I believe documentations. So I actually had a question around that. I believe I saw somewhere that we expect documentation to be on some CSI portal. There's already a README at the root of the plugin watcher API, but I believe there's also some documentation somewhere that's expected.
Yeah, we have developer documentation in the Kubernetes-CSI repo, and we aim to update that to basically specify how all of this should work on the CSI side.
Okay.
We may also need to update the device plugin documentation with the instructions for the new release. How, if people want to use probe mode, what actions they should take.
CSI, Kubernetes CSI, okay. I'm happy to take care of that. Let me check when is the deadline for docs though. Well, okay, I'll try. Well, can there be 2 owners on this?
Yep, let's break it into 2 items, and then the CSI side of things, Vlad and Sergey, and then you guys can take the device plugin one.
Yep. And then Sergey. Whoops. I think everything is done on this side. Finalize the GRPC API. That's basically 5 minutes. I can take care of that.
Yep. One thing that I was thinking about doing was seeing if we can push this GRPC API into the CSI spec. I'll pursue that offline as an independent project. It shouldn't change anything here. It will just affect the way that we consume it, whether we have to create a separate service for it or if the CSI driver can own it, but that doesn't affect this, so you don't have to track it here.
Okay, how would that work with the device plugin though? Would the device plugin also have its own service? Or
I think the idea would be that the service here is identical, just that CSI spec imports it and says, oh, it's part of the CSI spec as well. So that when you implement a CSI driver, you also have to implement this. In general, the CSI spec has a very high bar for getting things in it, so it's likely that it won't go in, but if it does, it makes our life easier because we don't have to maintain 2 services, one for this and one for the driver. But none of that should matter to you.
Okay. So I'll finish to wrap up that document. I'll send it. I'll add a table at the beginning for a sign off from everyone. And I'll send it to everyone who's present here. And hopefully we can move forward quickly on this. Does that sound like a reasonable plan for everyone?
Yeah, that seems reasonable to me.
Yeah, thanks for sharing this.
Well, I guess most of this is on me to finish that document. Thank you, everyone.
Cool, thank you. And if the CSI folks can stay on the call, we can carry on our discussion.
Okay. Thank you. I will drop off.
Thank you.
Thank you. All right, so I think that was pretty productive. Looks like we should be able to get the device plugin stuff done in V12 to move that to beta. So that means that we're looking good for GA in Q4. One thing I really don't like right now with the device plugin is the 2-socket thing that we have. So the way that it currently works is we have the driver registrar that drops a socket, and that socket is discovered by this mechanism that Renaud was talking about, and then it does this GRPC that they have to register with the kubelet, and then during that registration process, it advertises a second Unix domain socket, which is where the driver is actually sitting. And that gets passed back in the callback to the CSI kubelet code. And when the CSI kubelet code needs to talk to the driver, it uses that second socket. And if you look at the way that we've implemented it, Sergey implemented it last quarter as a a optional parameter on the driver registrar binary. If you look at it, it says, here's the path to the second socket. And I think when we were implementing it, we agreed that it was pretty confusing. So if you're trying to implement a CSI driver, you need to understand what the heck this means. Like, how does this thing work end to end? Oh, there's two different sockets. And oh, by the way, I need to make sure that my driver registrar has this parameter set to the second socket. All of it is one-time pain, but if we can reduce it, that would be very nice. There's two ways that we could reduce that pain. One is, both of them essentially boil down to, instead of having two different Unix domain sockets, have one Unix domain socket. And there's two ways to end up with one Unix domain socket. One is that the CSI spec gets updated to import this as part of the CSI spec, so that the registration happens on the same socket as everything else for CSI. I'm going to create a proposal against the CSI spec to propose that, but my guess is that it's probably not going to go in. So we need to also explore the second option, and the second option is that the driver registrar becomes the only socket that we have, and everything gets proxied through the driver registrar. So the driver registrar shares a private socket with the driver, and any plugin registration calls it'll handle on its own, and any driver calls it proxies through to the driver. I wanted to get your thoughts on that, especially Vlad and Sergey. What do you guys think about that?
My only pushback on the second option you mentioned, which is the proxy, is any speed penalty, because now we're introducing, we're not sharing tons of data in between the 2 points, but it's still an additional layer on top of, in between.
We're adding a point of
the
failure.
Consumer and a point of failure, yes, you're right.
Yeah.
But other than that, yeah.
The trade-off then becomes, what you mentioned, or the difficulty of setting up a driver. What we can say is, hey, yeah, it's a pain in the ass to set up a new driver, but you only have to do it once, and only the storage vendor has to do it. None of this complexity is technically exposed to the end user. If the driver vendor author sets up their YAML files correctly, the user doesn't even have to worry about this stuff.
The ideal solution would still be, I guess, to implement it in the CSI spec, and I think it makes sense. It's a fairly generic. Registration. It's not the Kubernetes specific, so other vendors could potentially use this functionality. If they don't want, fine. It's not mandatory. It's optional.
That could work, but my only concern with exposing the registration functionality, in CSI, is that now the device plugin API has now a dependency on CSI, because if anything, if we have
it would be vice versa. Like this device plugin GRPC would be defined in Kubernetes, and CSI would take a dependency on that.
Okay, so the driver would initiate the registration, or Kubernetes would initiate registration?
Kubernetes would still initiate the registration. Like the mechanism would be identical. Okay. As far as like the end user is concerned, whether it's part of the CSI spec or part of our separate spec, it's still all initiated by kubelet. What I was saying is, like, concretely in the code, in the CSI spec, what I imagine this to look like is that the CSI spec now has a dependency on Kubernetes and imports this GRPC that's defined in Kubernetes and exposes it as part of the CSI spec.
But let's say if on CSI side, the signature of the call matches whatever is used on the Kubernetes side, then there shouldn't be any problem, right?
Is also possible. That means that there's no explicit dependency. But the problem with that, I think, is that you could end up with skew. So if somebody updates CSI, then our side breaks, or if somebody updates it on our side, CSI breaks. So
Yes.
instead, what I would like to do
and
is
that's what
instead what I want is one place where we define it, and then it's imported in the other place. So defining it it's already defined in Kubernetes. So what we could do is just import it in the CSI side and expose it, or we could move it into a third-party package that both Kubernetes and CSI import from.
Okay. Yeah. I mean, when introducing a dependency in CSI, I'm not sure how the rest of the population is going to feel about that.
Which is why I feel like it's probably going to get a lot of pushback.
Yeah.
And,
I mean,
yeah,
we could certainly certainly introduce a message signature in CSI that looks like what we're using now. Just, something, because at one point in CSI, we did have discovery.
Yeah.
So
we could do that, but
have a discovery.
then you have the issue of skew, right? Like, so if somebody modifies something on the CSI side, now the Kubernetes side needs to go ahead.
Oh, absolutely.
And that can get pretty.
And I think, yeah, I think as soon as we have that coupling happen,
yeah,
any solution will leave Kubernetes exposed to, or this whole thing will be exposed to change on either side. Even if we were to do a third-party package, if that package change, then everybody's using CSI would have to possibly get affected.
Yeah. But I think the way that we say it works today is that CSI has versions that we release, 0.3, 0.4.
Yeah.
So every version that releases basically snaps to some specific version of this package.
Yep.
And as long as we do that, CSI should be happy, and whoever is consuming it knows, okay, this is the version of this package that I need to pick up. So I think the cleanest design would be that you release this thing as a separate third-party package, and it's versioned, and then both CSI and Kubernetes can snap to specific versions of it. But that's a lot of work, and it's pretty hard to convince both these communities that it's in their best interest.
Yeah. I was always wondering why. What if we ask the kubelet guys to run a service, and then CSI can
call into
initiate I think we talked about that, but for some reason it didn't work.
Yeah,
I forgot why.
That was early on in this discussion, was whether kubelet should probe for volume plugins or volume plugins should call out to kubelet. And ultimately the decision was that kubelet should probe for plugins, because if the kubelet crashes and comes back and the plugins are responsible for registering themselves, they're not going to know that, hey, the kubelet crashed and I need to re-register myself. So then, it depends on whether they're going to retry at what rate. It's more robust to have a design where kubelet can crash, come back, and then easily rediscover all the plugins that it's supposed to be aware of.
It's a bit funny. At first, when you describe the current state, I mean, it looked so ugly, but after all these discussions, it actually not that bad.
There's a reason we did it.
Right. I mean, we put some time behind it, but I think one of the reasons why we ended up doing it this way is because it doesn't force us to touch anything else, because the proxy, not the proxy, but the sidecar proxies everything else not proxies, but abstracts away everything else for us, where changes could could be required.
Hmm.
I mean, so I'll ask Sergey, because I think you probably wrote a driver that you had to deploy with that. Was that super painful, or I mean, how did you feel about it?
Well, I mean, at first, yeah, it was kind of confusing, but once I got the idea, I mean, it seemed okay, yeah, it makes sense. So
Yeah.
the initial
No.
step would be a little bit rough, but once people
I
get it,
mean, from a user writing a YAML to do this, how did you feel about that?
oh, oh, I mean, I think it again after the understanding of the concept, getting YAML was easy.
Yeah, I think
And
the
if we
other thing
provide
is
an
like
example, you know, so it shouldn't be.
Sergey also wrote the feature, so you know,
Right. So
have the
it's
best
probably not a
yeah.
not a typical. Yeah.
I think like one answer is that we could document the shit out of this, right? Like have very clear, extensive documentation saying, here is what's going on. Here's how this thing works end to end. Here are the fields that you need to be aware of. Here's why it looks like the way it does. We can do that. That's a third option. I'm going to kind of leave it up to you guys to decide which one of those three options is the best. And in fact, the CSI, getting into the CSI spec, we could try to do regardless. So it's basically two options. Do you want to implement a proxy server, or do you want to implement documentation?
Yeah. I mean, if we were to go to the proxy, I mean, I don't think I have anything against the proxy server. We just got to make sure that, you know, it's fast, and it could be even a proxy to where all we're doing is managing the socket endpoints, not necessarily proxying traffic, but just make sure the sockets are in the right place, and on one side the driver knows where to go and talk to the registration piece, and the registration piece knows where to. But
actually, you know what?
Because it's
somebody
prax.
was mentioning that you could actually have multiple callers on a socket, on a single Unix domain socket. So you could have a single Unix domain socket and multiple callers that
Absolutely.
call. Is the same thing true for servers? Could you have two servers sitting on the same socket?
Not on the same socket, no.
Okay.
No, it's gonna fail. It's gonna say
client,
it is
yes.
busy. Yeah.
Yeah. So then what you're
The client,
suggesting?
yes, but not.
So you're suggesting some sort of lightweight,
lightweight proxy, and all it does is manage the socket file. I mean, the socket locations.
So
but it would
would
look
it
at as if. So it would. I mean, basically what we're doing in our in the current implementation, that piece would do it for us. Basically, it knows where to talk to the driver, instead of the driver, and is responsible to. I guess let me think about it more.
Okay.
But basically, instead of proxying traffic directly, but manage the location of the socket files.
Yeah, the only problem with the location of the socket file is if you remove the socket, that is a explicit deregistration signal. So
yeah, that's fine. No, so what I'm saying is that the proxy piece we're talking about, rather than it proxying traffic.
Oh, I see what you're saying. So basically, you could still have the file exist, but you could have different servers come in and register with it and then deregister.
Well, no, we only have one proxy per driver, right?
Mm-hmm.
So let's say you have proxy comes up, and the proxy knows to put the proxy knows where to contact the registration piece.
Yep.
Registration happens, gives the registrar the information,
mm-hmm.
and then now the proxy. Oh, I see. Because
Yeah, it has to pass messages. I mean, there is no way to be transparent here completely. There's an intermediary.
Yeah.
Yeah.
You know what? I'm wondering if you just create a symlink to a proxy to a socket file. Anyway.
Yeah, I was thinking
I
about
guess,
that, but then the problem is that if you ever switch over to your driver and the CSI decides it wants to, or a kubelet decides it wants to register again because it crashed, then we're screwed because our CSI driver doesn't know how to answer that.
Yeah, because once you do the registration, whatever path you're registering is the path you're going to use for traffic, subsequent traffic. And that is...
Yeah.
All right, let me think about that.
Yeah, go ahead and think about it. That's an option. It might be cleaner in terms of being able to use this thing and explaining it to people. Everyone understands the concept of a proxy, so that's pretty easy to get people to understand and pretty easy to configure. It's a pain in the ass for us to develop, and it potentially introduces more latency and another point of failure. But on the reverse side, the current configuration that we have for the driver registrar is very difficult to understand. So I'll leave that to you guys to figure out. In the meantime, I'll start.
One quick question.
Sure.
So if we do the proxy, we still need there's still a need for a path, or a socket path between the proxy piece and the driver.
Yes, and that's just going to be a private empty dir.
Okay.
And
I just want to make sure that's okay.
Yeah.
So that still exists.
Yep, that still exists. And that's okay because it's easier to communicate. You have this proxy, and then the proxy exposes a Unix domain socket to the host, and then there's a private Unix domain socket between the proxy and the driver that's done through an empty dir. Versus like, hey, there's two sockets, they're both exposed on the host, and by the way, you also need to tell the driver registrar what the path to that second socket is, and wait, why do I have two sockets? What's going on?
And so the private socket would be configurable via YAML, etc.
Yeah.
And then that's all you would need.
But does it have to? I mean, it's a private socket. It should be. It's not exposed anywhere, so it could be even hard coded.
Yeah, you could hard code it. So you could just say like it's always going to be at a specific path, and then your empty dir, as long as it's mounted at that path, everything works.
I have one question about the empty dir. There was some discussion that how reliable is to use the empty dir for the socket for the case of the plugin driver restart.
If the driver is restarted, as long as the pod exists, you're fine.
Okay.
So container restarts, the empty dir just gets mounted into the container after it started. So it's the same empty dir, everything should be fine.
Cool.
All right, so that's going to be fun. I'll leave that to you guys. Second thing, I've got Jan on the call. So Jan, I talked to SIG Architecture yesterday about the CRD. Their recommendation is that they are okay with us having some private controller that will install the CRD, or having attached detached controller install it. Basically, we can have some internal Kubernetes component install it. They're also okay with us using an add-on if we wanted to, outside external. But it sounds like for us it'll be nicer if we could have an internal component that installs it.
Yeah. If you notice my email, I tried to use CRD in Kubernetes to do the shadow mode, and it's terribly painful. Like in API machinery, we have a lot of tools to how to generate code for the internal API, but we have less code for generating CRDs. So yeah, it's quite painful. I sent an email to this group.
Okay.
You can send the summary there, but we will need to go through the unexplored path. Actually, using internal IP.
Would it be easier if it was external?
Well, not really. Well, I need to use the API from SSH controller anyway. So.
Yeah. Okay.
It seems it is possible, but it's just harder.
Okay.
Are you referring to the generating the code for the client Go to talk to the CRD objects?
Yeah, I can generate CRD. The client. I can generate informers, but I can't get validation. I can't get conversion between the versions, and this kind of stuff.
Oh, yeah, this is coming. I mean, there's a validation, and it's done via webhooks. And we do it like I do it on some other projects, so it's doable. But you're right, it's not straightforward. It requires additional components to accomplish that.
Yeah.
So what kind of validation do we want here?
I don't know. Quite minimal. We can have regular expressions for validation. That's okay in CRD. It could be enough in the first step, I guess.
The webhook validation is going to be better, right? Because we need to have some sort of external component that's going to sit there. When a new CRD is created, it can do the validation. So it's not going to be part of the core.
It's possible, but I wouldn't worry about validation right now. We will have just the driver name and boolean.
Yeah, true. Okay, so that could be a V2.
But, my question would be, does this CRD need to go through API review?
Kind of, yes. Since we're going to advertise it as like a core component, yes, I think it will.
Okay, so what is the reason why we don't use entry API?
Because there is no. So I asked this yesterday, and their answer is basically there is no more entry API. Actually, I was talking about this separate from that discussion. Moving forward in 2 years, there will be no entry API. The only thing entry is going to be namespaces and maybe a little bit other API machinery thing. Everything else is going to be a CRD. Even the core things like pods and nodes are going to end up being CRDs. So CRDs are going to be a mechanism for the API. And they want to basically draw the line now.
Yeah, and I don't want to be the first.
I hate it too. I fought this fight very hard when we were doing snapshots, and they shut us down. They said no.
Okay.
Yeah, it sucks for us because we end up straddling this line between in and out, and we have to be the first ones that go and discover all the painful things with this. But we don't have a choice.
Okay, then I would propose if we have to do CRDs, there is a code in somewhere, I think it is in API server, who insert RBAC rules, like hard-coded rules. It puts them into the newly created API server.
Okay.
So it could be a good place where to put just the CRDs we need. And the second thing I wanted to clarify, we will have the registry, like one on controller plane, one object per driver with name and attachability flag, right? And on the node level, do we need anything, or should we do just schedule node thing?
So on the node thing, I think the biggest driver is going to be this.
I was thinking that moving the things we have in annotations to status could be easier.
Yeah, it definitely would be easier. I would be okay with that if we can get sign off on it. I know Tim immediately suggested doing a second object, but if we can get sign off doing just a field on the node status, I'm okay with that. So we might have to ask the node team if they're okay with it. And if they're okay with it, let's do that. Path of least resistance, basically.
Yeah, exactly. Okay, thanks.
Cool. And just to be clear, you are pursuing the node one, and it sounds like you have some work done on the CRD for this as well.
Yes.
Okay.
So I just tried to put some CRD and read it from a node and get events from the node.
Got it.
And that's it.
Okay.
There's no content, no API.
And the email that you sent, have you shared this code or?
No.
Okay. If you could share that, that would be a good starting point too.
Ooh, okay. Okay.
All right, cool. Thank you very much. I think we're well over time for today's meeting. Is there anything else anybody wants to talk about? Okay, so I think we all have a lot on our plates and a lot left to do this quarter. So let's reconvene on Monday. Actually, let me double check my calendar to ensure I can join on Monday, because there's another meeting at the same time. No, I should be able to join on Monday.
Are you still in Tel Aviv, or are you back in the States?
No, I'm back in the States. All right, so that's all I have. Anything else anybody wants to talk about? All right, cool. Then see you on Monday.
Thanks. Bye-bye.
Take care.
Bye.
Bye.